Hello and good afternoon. So today I'd like to discuss about an electronic instrument which is frequency counter. I would like to mention that we were asked to design a schematic or a circuit for a frequency counter. So before beginning the work, I would like to define this instrument. This instrument it measures frequency, which means that it usually measures the number of cycles of oscillation or the pulses per second in a periodic electronic signal. So, secondly, I would like to introduce the components that we have used to construct our circuit. So, as you can see, we have used a 7 segment for displaying, decoder for displaying, and also a clock to adjust the frequency, and a button to reset the circuit, and also, last but not least, a 34026 ICs. So I would like to talk a little bit more about this IC. As you can see from this diagram, it has about 16 pins. Each pin has its own function. For the first one will be the clock. The counting only happens when this clock is high. For the second one will be always connected to grounding in order to make the clock work, and also to enable the clock. And also for the third pin, which should be always high in order to enable the output from A to G. The fourth one will always stay high also. And for the fifth one will be a divided by 10 bin, which means it's a carry over bin. The counting, which means it produces a pulse when the counting reaches 9. From bin 6 to bin 13, excluding 8, which is grounding, these are all connected to the decoder for counting. The 14th one will be rarely used. It's only used when the division is required. And the reset bin over here, we have it. It's reset the counting to 0 only when it's made high. Last but not least, this VCC will power the whole IC with a 5-volt power, and that's all.
So we know about the component. Let's now start to construct the circuit. Starting here, we see the clock will be connected with the pin number 1, which indicates the clocks, and the pin number 2 will be connected with the ground right here. So all the ICs, pin number 2 will be connected with the ground. This one also here for the clock number 1, for the IC number 2 and 3 will be connected with the pin number 5 to connect between the ICs. So here for the pin number 3, which indicates the enable pin will be connected with the PC power. Okay, all pins number 3 will be connected with the VCC. And finally we see the reset pin, which will be connected with the reset button, and same goes with the other ICs. Now we will try to connect the 7th segment with the IC, with pin number 10 to number 7. And for this pin, will be connected with the ground. And all will be connected in one point to be connected to the ground. So here we complete our step this one. We connect it with the AC power to complete the supply power for the circuit. So this was for the constructing the circuit. After that, now will be moved to the show how this circuit will be simulation.
As mentioned earlier, we have used 4026 IC. This is also a 7-segment display decade counter which counts from 0 to 999. Here we have used 34026 IC and implemented 3-digit counter circuit which counts from 0 to 999. If we want to count more than this, we need to add more ICs. Here we have provided a clock to give the input. Our IC is now set to 1 Hz. Now we will run the simulation. Here, this is a reset button to reset the whole program. If we want to count fast, then we need to give more frequency. Now it will count faster than before.
Now I will talk about the features of ICCD4026. It has counter for 7-segment display. It can drive a common cathode 7-segment display directly. It can be easily to interface with the timer or microcontrollers. It can be easily cascaded with more IC to display higher range of number. Its maximum clock frequency 6 MHz. It also available in 16-pin PDIP, GDIP, PDISO packages. Now I will talk about the application of frequency counter. The frequency counter can accurately measures the frequency, the time interval, the phase, and the event, etc. The frequency counter function is designed according to its application. The most common application of the frequency counter is to determine the characteristics of the transmitter and the receiver. Other applications of the frequency counter include the computer field, which uses a high performance clocking, data communications, microprocessors, and displays. The early applications of the frequency counter is as part of signal generator, and it also used in 7-segment counter projects. It can be used to count people or objects crossing a point. It has capability to display a wide range of numbers from 0 to 999. It also used in project where microcontrollers should be avoided.